Hi everyone. Today I have to discuss about diagnosis of pest attacks on mango plant using deep transfer learning techniques, which were done by Gangu Prithviraj, Tadikonda Shivashankar, and me, Marimuthu Murthy. This project was supervised by Mrs. Pranchana Devi K. She works as an assistant professor in Veltech University. Okay. Then the main core of this project is deep learning. Why you choose deep learning is deep learning is best for the image patterns classification. So I have to choose this technology, deep learning. Okay. Then this is our agenda. We have to discuss about abstract, what is the objective of the project, and the introduction, and who are done this project in this past, and the design and methodologies of these projects, and what are the standards and policies we are using in it, and we have how we are implement this project, and how to test this project, and input on output which are given by us, and including conclusion, future enhancements, and references. Okay, this is totally done by us, so we think our plagiarism is less. Okay, this is for abstract. So I have to mention that when we are in childhood days and the summer games, we purely like for the mangoes, right? Mangoes is an all favorite fruit, but we think that we give the money and buy the fruits, but which is cultivated by farmers, they feel more difficult because agriculture or cultivation of the mango tree is more difficult. If one plant is diseased, it means it spreads to all the trees or all the plants. So it causes damage to all the plants and causes much more damage. So it leads to the farmers uh, farmers death. We have to hear that news like farmers are committed to the suicide because of his less profit in agriculture. So we have to choose this fruit as our test. Okay. This is the main objective of the main aim of the project is to improve the mango quantity and the quality which were produced by the farmer and reduce the financial loss for the farmers who are invested in them. And we have to hear that the farmers so much are uneducated, means illiterate. They don't know how to use the technology. So we introduce that modern technology to cultivate the crops, which helping for the new methods of cultivation works. Okay. Then the scope of the project. So the scope of the project is very simple. We have to detect the diseases early and show the quick way to resolve them to the farmers. Okay, which reduces the massive damage from spreading the diseases by using pre-trained network model. Sounds like good. Okay, introduction. So I have said that early now. Mangoes occupies a vital role among all the fruits in India because mango well grows in India, right? But all the farmers in India are less illiterate. They don't know. They only know how to cultivate it, but they don't know how to prevent it quickly and more efficiently because technology grows us. All are developed very well, but the farmers they don't utilize the modern technology. So we have to introduce this one to identify the disease quickly and give the efficient solution how to solve the net. Okay. I have to mention some names which are anthracnose, bacterial flower disease, and gomalchi, morica disease, and shatty mold, bacteria, black spot, and apical bud neurosis, red rust, lichens, powdery mildew, root, and damp of Ganoderma root. These are the names of the diseases which are spreads in the mango fruits and the leaves, which causes a massive damage. Okay. See, we all know that the disease names like we know that if the fruit is some have some black marks in it, we classify it as the disease of fruit. But I mentioned some of the names which are all the diseases which are occurred in the mango fruits. So we have to identify these diseases and give the solution how to prevent it. Okay. Among all these diseases, powdery mildew causes some large number of affects the large number of mango trees in the majority of the countries throughout the world, which causes damage of 23% of the untreated trees to die. Okay. Here first, um, we have all know that the artificial intelligence, right? Machine learning is a part of artificial intelligence. So artificial intelligence is used to machine learning is used to predict something, but deep learning is a part of machine learning. So we use the deep learning for the efficient purpose. Mainly the core of the deep learning is image pattern. Okay. Yeah, because we know that the leaves which are seen by us is an projection like image. So it does not have data. We have to collect the pictures and convert into data, and we have to train the model. So we have to choose a deep learning.
Literature review. These are the our we are to, these are the papers we have references and we go now we go to we go through the design and methodologies, module 1 and module 2, module 3 and module 4. We divide into the 4 parts. And dataset collections. These are the dataset collections, and we use in this project ResNet network for developing the model, and we train that network, pre-trained network. These are the we seen these are the leaves which are affected by the viruses and diseases. And we go to the next slide. Leaf diseases, we are importing data sets. Here we can see, and these are healthy images, and these are unhealthy images. We are going to train the model by using the ResNet. We importing the data set from the Kaggle, and for training purposes we are using to maximum out of 40,000 images. We are using now 20,000 images for graphing purposes for sampling the data and training the training the model. And we are uploaded to the drive, and we are importing from the drive, and we are using the platform for training the data, training the model. That's the Colab, and we are importing the libraries from Keras libraries used because it's efficient to do that this neural networks and all. And when we are using the Keras libraries, it's possible to go with long neural networks. It's made possible, and these are the validation process with using the ResNet. We can see here this page how validation are going on when model was in process. These are the validation images. We can see there uh, the what is the image and what is the image affected by which disease name. The standards and policies of their use. TensorFlow standard use ISO NIST 27002 and Google Collaborative standard. These are same, and these are architecture diagram for our project. We take basic architecture diagram is well, and first we are taking the image from the outsource and taking image and importing the image to model, and the model extracting extracting the future of the images and detecting the image future extraction is detecting by the CNN model. The model was on ResNet. Why we are using ResNet means when we are going to handle with a large amount of image data, it's efficient to do the work. So we are using ResNet compared to other networks. It's better. Image and we are trained at the training the model, and the model will identify the disease early. Data flow diagram is the first. Data collection, importing data set from the data, and data validation is the image is a real image, that mango or any other image. In this step it will find, and if it is valid it will go through the next step, or it's invalid it's stopped there. And importing the libraries from Keras, and data pre-processing here after the importing libraries, and model or test or training. These steps, if you are doing a training, then its step is training and predicting softmax. In this ResNet, softmax is important to predict the output, because in neural network so many outputs are coming. In ResNet, we are talking about ResNet here. In ResNet, so in deeper the network trains and deeper goes, and the model which is easier to give the output by using the softmax, data optimizing by the softmax. After that, data fitting by the model and show the output to user. This is the data flow diagram briefly, and we are coming to the ER diagram. Basically, ER diagram means what we are doing, that the relations between the entity relations between our and data collection from the reviewed data set and live forms. The collection database comes to the pre-processing step. After that, we are using deep transfer learning techniques. Why deep transfer learning techniques? Means we are doing the process that we are training the image. We're training with image to model. We can use the same model with minor changes. With the model can be able to use for other projects also. This is the deep transfer learning technique. That's why we are using. And testing phase, after training and testing phase, the processing will done by the model and output shown to the user. That's the brief about here diagram. Sequential diagram is a sequential diagram. It means basically it shows the what the sequence of the flow of program or any project inside neural model network configuration weight. These are the weights, weight computation and weight computation too, and train cross validation of network, test on network. We can, this is the neural network module, ResNet as weighting, and configure the different layer of network. In other networks, the weights may be changed from input to output. The size of image will be decreased or reduced, or it can't be efficient to do the project with when handled with the image large amount of image data sets. In here, when we take the larger input and when we take the larger training data, that output goes to be highly efficient with using of ResNet 152 v2. 152 means layers of the model, v2 means version of the data, and if image validation is, if it is not valid, it's staggered at same new configuration validation point and initial weight biases, and we are using the the weight is equal to output weight of image. It's configuring the maintaining same weight of image by using this function. Update weights and adding real image. We are when we are going to the neural network, they decreasing the size of image after perceptrons running. When was the perceptron decreasing the image size? After the next perceptron, next layer perceptron will taking the same input output of the before perceptron. It's maybe difficult to take output up at the end of the day, and train the model with ResNet 15v2. It maintains the output and input weights and taking the and training the model to give the best efficient output. The collaboration diagram. Windows on interface from Windows interface. This collaboration diagram means is the easy process to communicate with machine and human. Validation of image, training and testing phase, and processing image and confirmation and decision. Sending a message from the Windows interface and image. Validation of image is checking here, and training and testing. If checking here is the image is good or bad. Here processing image is there. There is divided into two parts of data, and here is something which one is a disease leaf, which one is normal leaf. That's about collaboration diagram. Here is the testing phases. What we are tested here: unit testing and integration testing and functional testings. Finally, our input and output. As we given this input and input to the model, and it's given the accuracy, and as we are trained with 1000 images, this image is shown the ResNet, the training and validation accuracy graph. Here we can see the validation is accuracy lesser than training accuracy, because here we can say the names, and we can training in at the training part we are saying the names and what images to the machine or model. That's why it here given high accuracy, and this image come to this image, and training and validation losses is showing, and the graph showing the 7 epochs and 1,000 images. The graph here, training loss is very less, and validation loss is compared to training loss is high. Finally, conclusion of our project: accuracy losses as well as parameters and epochs for each model during training comparatively analyzed. We considered all parameters to determine best fitting model, and that high accuracy and good performance for classification of mango leaf images. Data was collected and trained using deep transfer learning algorithms, and the predicted data has been tested. It also shown that using the state-of-the-art deep transfer learning model with the pre-trained model leads better outcomes and higher detection accuracy, and it provides a feasibility conclusion and real-time detection of mango leaf diseases. In this project, we concluded that residual network and is suited for diagnosing the disease in mango image datasets. It's giving the output high efficiency and accuracy with low error rate and less data loss than time of model training. Here, the coming compared to other networks, we are concluding when compared to other networks. Here training time is very high compared to that, and testing is very fast when compared to other networks like VGG and other LeanNet or any other network. It handles large amount of data, and it handles big image, large amount of image data sets. It gives high efficiency compared to other pre-trained models. Future enhancement: nowadays critical to detect the diseases in plant during early stages in order to improve the yield, productivity, and quality. Because disease identification necessitates high level of knowledge, it would be ideal if we could install this system on my smartphone, allowing the farmer snap a photo of leaf and upload it to server. The server will recognize the classify the alignment and deliver the results as well as any prescribed medication to the smartphone. This is the it shows the what disease and which leaf is disease leaf, and it's predicting from the data sets, and is classifying it. These are differences what and plagiarism report of a project. This is the poster presentation of project we done. Concluding our project. Thank you. And this project done by team members Gangu Prithviraj, Malmurthy Murthy, and myself, Shivashankar, and supervised by K. Kanchana Devi, assistant professor. Thank you.